everyone. Today I will be presenting a research analysis titled Human and Equipment Factors Affecting Image Quality and Film Rejection, a multi-center study. So this study focuses on analyzing differences in image quality and film rejection rates across several radiologic centers. Now let's move forward to the hypothesis of this study. The hypothesis is that the film rejection rates differ among radiologic centers. The researchers also wanted to see if the equipment age and technology workload were related to higher rejection rates. They investigated whether these differences were significant enough to affect diagnostic accuracy and workflow efficiency. So the goal of this project is to understand how statistical tools are applied in real radiologic technology research. For this presentation, I will show how statistics help support the hypothesis in this study and how it contributed to decision making in imaging science. So, compared to other qualitative approaches, this research uses a fully quantitative method which relies on numerical data, group comparison, and statistical significance tests to analyze performance across radiologic centers. For the data types, so the independent variable in this study is the hospital centers, which is a categorical variable. The dependent variables are rejection rates and image quality scores, which are continuous data. The study used one-way ANOVA to compare the film rejection rates among the different centers. ANOVA is used when we want to compare the means of more than two groups, which makes it the correct tool for this multi-center study. So why was the ANOVA used? So ANOVA was appropriate because again the study involves multiple groups of centers. The data were continuous such as the percentage and the image quality scores. So each group was independent and the data were approximately normal distributed, meeting the ANOVA's requirements. So a TITAS would not work here because the TITAS only compares two groups while this study compares more than two. So compared to other qualitative approaches, this research uses a fully quantitative method which relies on numerical data, group comparison, and statistical significance tests to analyze performance across radiologic center. So this concludes my report on human and equipment factors affecting image quality and film rejection, a multi-center study. Thank you for listening, and I will now give the floor to Bea.
Good day, everyone. My presentation today is on quantitative analysis in radiologic technology. Specifically, we will be walking through a case study focused on evaluating attitudes using statistical application. This presentation covers project case study number 2, which delves into the attitudes towards study major and career prospects among students and graduates in radiologic technology. The central motivation for this study is that attitudes matter. Research has identified a critical link between a student's attitude towards their major and the quality of their future professional work. The main objective was to assess the current attitudes of students and graduates. This assessment helps to detect potential issues like a lack of interest or negative perceptions about the job market. Ultimately, this gathered data is vital for informing curriculum and career counseling improvements. Let's look at the methodology. The design was cross-sectional. This means data was collected at a single point in time, providing a snapshot of current attitudes rather than tracking changes over years. It was also a descriptive study. The primary aim was simply to describe the current state of affairs, the attitudes, and their distributions, without manipulating any variables. Finally, the data collection was survey-based. An online questionnaire was administered to 120 participants, including both current BSc students and recent graduates. To understand the analysis tools, we must first understand the data types. The key data, the attitude scores, were gathered using a 5-point Likert scale, from strongly disagree to strongly agree. These are treated as interval data. The scores were aggregated into means so they could be treated as continuous data for statistical analysis. The second type is demographics, which serve as categorical variables. And these include variables like gender, student versus graduate status, and employment status, which act as the grouping categories for comparison. The first statistical tool used was the independent samples t-test. This tool is used to compare the average attitude scores of two distinct non-overlapping groups. A perfect example is comparing the mean attitude score of current students versus graduates. The goal is to determine if there is a statistically significant difference between the average attitudes of these two specific populations. Next, we have the one-way ANOVA. Since a t-test is limited to comparing only two groups, ANOVA was required when the demographic variable had three or more categories. For instance, it can be used for comparing attitudes across second-year students versus third-year students versus fourth-year students. The goal here is to determine if attitudes shift significantly as students progress through the academic program. The final tool is the chi-square test. Unlike the t-test and ANOVA, the chi-square test does not compare mean scores. Instead, it analyzes the relationship or association between two categorical variables. An application of this is asking, is there a relationship between gender and the belief that job opportunities are sufficient? The result helps researchers identify if specific demographic groups are more prone to certain categorical opinions. The key takeaway for the selection of these tools is the strict rule of matching tool to data. The type of data you have dictates the statistical test you must use. For interval data compared across two groups, you use a t-test. For interval data compared across three or more groups, you use ANOVA. For comparing categorical data with other categorical data, you use the chi-square test. Using the specific appropriate tools allows the researchers to move beyond guessing and provide statistically valid evidence to support their conclusions.